this video, I will be explaining what is the average rate of change. If f is a function, then the average rate of change of fx with respect to x as x changes is given by this formula. The average rate of change equal the change in the function, the change in the image of the variable, divided by the change in the independent variable. So, for example, if x changes from a to b, when I say the change in fx is just the difference between the last value of that x has minus the first value. So when I say that x changes from a to b, so this change in x will be b minus a. So the second minus the first. If x changes from a to b, then what we have is we have a function. If f is a function, f is changing from the value a, let's see here, this value, to a value b, this value, and obviously each of these values have an image. If this value is part of the domain of the function, this value have an image. So it will be a value f of a, and this will be the value f of a. And this defines a point in the graph that is the point x f of x, or in this case, a f of a. So this point will be a f of a. A will be the value of x, f of a will be the value of y. And the same happens with b. If b is in the domain of the function, we'll have a value y equal f of b. So it have a point in the graph that defines an image of this function f of b. And this point in the graph will be b f of b. So we notice if x changes from a to b, then the value of the function changes from a to fb. So the changes in x will be b minus a, the second value minus the first. If I say they change from a to b, then will be b minus a. And the value of the function have changed from fa to fb. So it will be fb minus fa. So this change in fx will be fb minus fa. The change in x will be b minus a. So we can type that the average rate of change is f of b minus f of a divided by b minus a. You will notice that this is actually the slope of this line, that is the secant line, the line that passes through these 2 points. This will be the rate of change. So the average rate is the slope of the line that passes through the 2 points, a f of a, b f of b. The line through 2 points is called the secant. So actually then the average rate of change is the slope of the secant line. For example, if we need to find the average of change for the given for a function like this f of x equal x squared minus 4x plus 1, when x is changing from x equal -2 and x equal 2. So it will be a first value and a second value. So we can use the formula and type that the average rate of change will be the function evaluated in the second value minus the function evaluated in the first value divided by the second value minus the first value. So the average rate of change will be f of 2 minus f of -2 divided by 2 minus -2. In each case, the only that we need to do to find the image of each value is substitute the value in the value of x. So that will be then 2 squared at the top, 2 squared minus 4 times 2 plus 1. This is f of 2. And the other minus, then the same thing, but instead of x, we are going to type -2. So we have that minus 2 squared minus 4 times -2 plus 1. And this will be divided by 2 plus 2. In this case, yes, 2 minus 2. That is 2 plus 2. So here the first value will be 2 squared 4 minus 8 plus 1. So it will be 4 minus 8 minus 4 plus 1, and this is -3. So we have here at the top -3. At the other side will be 4 minus plus 4, because the -4 times -2 is +8. So it will be 4 plus 8, 12, plus 1, 13. So it will be minus 13. And everything divided by 2 plus 2 equal 4. So we have that this is negative 16 over 4, and this is negative 4. This is the average rate of change. We can say that in average, the function is changing 4 units per unit change in the value of the independent variable. Or better, is decreasing 4 units, because we have a minus sign here, is decreasing 4 units for its unit change in the independent variable. If we want to see how the change looks in a graph, we can use a software for making a graph. For example, GeoGebra. I use GeoGebra to make the graph. I type the function in GeoGebra, and then I find the point A, the point B. So the point A was minus 2 f minus 2, the first point. So when the value of x equal negative 2, so it will be negative 2 f of negative 2, and this is minus 2, 13. So it's actually this point here in the graph. Then b equal to f of 2, so I just define 2 points A and B, and the line that passed through these 2 points, I can see this line if I type line AB. So if I do that, I see that the line is y equal minus 4x plus 5, this line here. But you notice that this line, the second line, is changing a unit per, so it's changing 4 units per unit change of x in average. And you notice here that there was 4 units change in x, and in these 4 units change there was a 16 unit change in the value of y, in the value of f of x. So it was changing from 13 to number negative 13. So there was a change of 16 units when there was a change of 4 units. So 16 over 4 equal 4. So actually this is the minus 4 that we have here, because it's a decreasing change, and so it's going down. So this is a negative slope. Let's see another example. Now we have the figure, and this figure shows the total sale in thousands of dollars from the distribution of X thousand catalogs. So this number 10 here, for example, is 10,000 catalogs, and this is 20,000 catalogs. This is 30,000 catalogs, etc. And for each value, we have the sale. For example, when we have 10,000 catalogs, I know that the sale was around 32.5 thousands of dollars. So this is the sales in dollars, and this will be in thousands of dollars, and this is the number of catalogs in thousands. So, and we want to find the average rate of change of sales with respect to the number of catalogs distributed for the given change in X. So these are the changes in X from 5 to 15. So from 5,000 to 15,000. B will be from 15,000 to 25,000, and C from 25,000 to 35,000. If I want to do this, then the average rate of change in A will be the value of the function in this 15 minus the value of the function in 5. So divided by 15 minus 5. I noticed that when x equals 15, the value of f of x equals 36. So this is the value of 15,000. There will be here 36,000. Because everything is in thousand, I don't need to type thousand. So I can type here that is 36 minus the value in 5, that is 26. It will be 36 minus 26 divided by 15 minus 5, that is 10. So this is just 10 over 10 equal 1. So I noted that the average rate of change between these two values is just 1. 1 unit change in sales, so $1 change per each catalog change. Notice that if we use thousands, here will be 10,000 divided by 10,000. So we can type it in this way without the thousand, because they have both units are multiplied by 1,000, so we can cancel this 1,000. So let's see what happens if it's changing from 25 to 25. So we do the same. So we are just practicing that we need to do the same, but I just want that you observe that this average rate of change can change also. And you notice here that f of 25, when x equals 25, the value is 41. The value of the function is 41. So here will be 41 minus 36. So it will be 41 minus 36 divided by, in this case, will be 25 minus 15. So it will be the same thing. So in this case, we have 5 over 10, and this is 1/2. So I noticed then that the average rate of change also changes. And you notice the change here. The slope between these 2 points is bigger than the slope between these 2 points. And for the last part, for C, will be f of 35 minus f of 25 divided by 35 minus 25. And we can see in the graph that is the f of 35 is 45, f of 25 is 41. So I just made 45 minus 41 divided by 10. And this is just 4 over 10, and this is just 2 over 5. And again, this is even smaller. So we observe that as more catalogs are distributed, sales increase, but at a smaller and a smaller rate. So the rate of change is changing. So this is my explanation about average rate of change that will be useful to define the derivative of a function.